So, hello, good people. How are you doing? So, I hope you are very well. So, today I'm going to discuss about a problem. You may have seen this problem in a lot of places. I know that many of you do not have problem with the first one, but I have personal problem with the second one, and I have seen in a very famous coaching institutions they have solve it in a very silly way. So today I gonna discuss about the very basic about this problem, and secondly, so what would be the exact solution to this problem. So let us start. So to start with, we are given a circular hemisphere with a mass m attached on the top. I mean, it is free to move. This is just placed on the top, and we have just given a very small force so that it starts moving. Very small force, I mean just a very small thing, so that it starts sliding down. So after some time it would break off the plane. I mean, how would be trajectory? Like, let us consider that the blue will be its trajectory. So let us think that this is the angle when it will break off the plane. So now it will be so that will be its trajectory. Okay. So this is the point where it breaks off. So we have to find the height and the angle. So if we find the angle, this is the main culprit. If we find this angle, then we will able to find each and everything. Okay. So now let us start. So let us understand the thing. So suppose if something breaks off a plane, like I am saying that, like, suppose we have a spring that is attached to such a mass m. So suppose now I am pressing it, uh, like I have given a mass m, or somehow I am just putting a force on it. So now it will break off the plane only and only when its normal force is equal to 0. So that is the moment it will break off the plane. So we have already discussed about this problem in my videos, so you can definitely check it out. I will give a link to the comment section, and we can understand this. When the normal force is 0, then we can calculate the theta, and we can also calculate the distance it has to travel before it breaks off. So the similar case is there, but we are given a circular hemisphere. So the problem is not too hard. We have to find just two equations. So let us find the first one. So the first one is that, suppose that it is moving on a circular plane. So there must be a kinetic energy. That means there must be a pseudo force working here. Okay. Now the pseudo force, and now we have mg cos theta. Okay. So mg cos theta. So you can understand pseudo force is always works. I mean, the pseudo force, it will always work outside this plane. Okay. I mean the normal to the plane. Okay. I mean, this is pseudo force, so it should be the direction along this, but no, it will not. It will just simply go towards this. Okay. So let us write our first equation. So mv square r is equal to, so what would be it equal to? First of all, the normal force, and secondly the mg cos theta. Mg cos theta is nothing but the component of this towards this. So I am just calculating the total normal force. Okay. So what I have earlier said, that the normal force has to be 0 in order to get there. Okay. So now if we just cut down, so we can have v square is equal to rg cos theta. So this is our first equation. So now let us consider with the second equation. So the second equation we will get from energy conservation. Okay. So this is our free body diagram. Okay. So the thing was firstly here. Okay. So if we consider this, so this is r, this is theta. So this is r minus r cos theta. Okay. So this is r cos theta. Okay. So now what we'll just do, I mean, this height is r cos theta. So now we'll just use, like, we need to find the velocity at this point. So mg r into 1 minus cos theta is equal to the point, the velocity at this point, okay, which is half mv square. So mgr is equal to half m v square is equal to rg cos theta, okay. So I mean r into 1 minus cos theta, okay, we will just see about this later, okay. So now we have gr, okay, grm all cross, okay. 1 minus cos theta into 2 is equal to cos theta. So 2 minus 2 cos theta is equal to cos theta, or 3 cos theta is equal to 2. So theta is equal to cos inverse 2 by 3. So that will be the final answer, okay. So that is the angular displacement of the particular object when it will break off from the ground, okay. So now let us move to our second problem. So according to some famous coaching, so what I have seen that they have just simply used that h is equal to r into 1 minus cos theta, okay. So as h is equal to r1 minus cos theta, so you have value of the theta, so just find the value of h, and t is equal to root over 2 h by g. But this is just not wrong, this is just basically wrong, and everything is wrong. This cannot be solved in that way, because you know what, let me explain. You can simply understand that this move, the force that is working on it is not actually a constant force. This is not a constant force, this is moving on the circular object because of a variable torque that is generated by the component of mg sin theta. The component of mg, and this component of mg sin theta is generating the torque in order to make it slide, okay. So now, so there are some special things that we need to realize here, okay. So the first thing is we have to write a equation, okay. So let us consider that this is moving along this circular path, okay. So this is moving along uh, this circular path. So now suppose it is breaking off from the ground, okay. So at the angle of theta it will break off from the ground, okay. Okay, so now we can understand that before breaking off the ground it was moving on a circular path. So we can understand there was a torque working on it. So there was a torque working on it, and we have understand from the free body diagram that this angle is theta, this is mg, and this is the mg sin theta, which is working tangentially to the circular hemisphere, okay. So now let us proceed. So what will we do? We will write tau is equal to r alpha. So let us use some vector, okay, r cos f. So now what we need is the magnitude of torque. So we can just simply write rf sin theta, okay. So now we can understand the f, the force that is generating is f, okay. So now r into mg sin theta into theta sin theta, okay. So that means r mg sin square theta. So tau, so I mean the torque, and also we know that tau is equal to I alpha, okay, and I is equal to, and as it was moving in this path, so we can understand the moment of inertia would be mr square divided by d omega by dt. We can write this mgr sin square theta, okay. So now let us consider that m is gone, okay. So now r, so now r and r, these are gone. So r is equal to d omega by dt is equal to sin square theta into g. So further we can write d square theta divided by dt square is equal to g sin square theta. So now we can find that this has turned to a second order differential equation, okay. So this has turned into a second order differential equation. So if we can solve this, then we are proceed to go, okay. So let us check what we can do. So in order to solve this differential equation, just you need to multiply it with d theta by dt. Okay, so now let us check what could happen. G sin square theta d theta by dt. Okay, so now what we can do, so we can see that if it is theta 1 square, so let us represent this as theta dash, and I mean theta dot. I think this will be more convenient for us. And secondly, let us think that this is theta double dash. Okay, so if we try to differentiate this, so this would be 2 theta dash into theta double dash. So now we need a 2, so let us multiply 2 on the both side. And now what, oh, I'm sorry, but I think I am getting out of my page. Okay, so I think this is a very crucial part, so I do not want any make mistake. Okay, so that is the thing. So we have multiplied a 2, and now what we gonna do is simply just replace this. Okay, so this simply look like this: theta into r is equal to 2g sin square theta into theta dot. Okay, so now this is theta 1 square, so this could be written as theta 1 square into r, and this could be written as 2g sin square theta into theta dot. Okay, so now what we can simply do is to integrate this. Okay, so if we integrate this, so listen, we have to integrate. So we have got this term by integrating. Okay, so we have to integrate this. Okay, so let us now integrate. So if we integrate, we will get that integration of sin square theta d theta, and there is a 2. So I think this is easy for us, cos theta d theta. So it will simply yield us theta by, yes, theta minus sin theta. Okay, so this is simply yield us to this equation. Okay, so now let us replace this r. So now let us go there. R theta dash square is equal to 2g sin square theta into integration, and now let us replace this with 2g into theta minus sin theta. Okay, so this is theta minus sin theta. Okay, so now r theta dash whole square. So now it has gradually turned into a first order differential equation. So now let us do another thing in order to solve this. Okay, so now let us square root both sides. Okay, so root over r is equal to theta 1 is equal to root over 2g into root over theta minus sin theta. So theta 1 dash or theta dot, so now let us just shift them it. So theta dot divided by root over theta minus sin theta is equal to root over 2g by r. Okay, so now we can simply write this as d theta divided by theta minus sin theta is equal to 2r by g into dt. Okay, so now what we simply do, so that is the equation to solve. So now let us put the limit. So now what I want to say, just you have to be cautious about one thing, that if you put the limit here, you can see that if you put a 0 here, you will get an error. Okay, because you are not, so let me explain that why it should give you an error, because it is not freely forming from an angle of 0 degree. Okay, it is not angle from, you have given a slight impulse, or you have a very small impulse or force that for which it starts moving. Okay, so you have to use a angle that is very small, like 0.0000001, and then put the upper limit cos inverse 2 by 3, and now just simply put this thing here. Okay, so now it will give us so now, and then multiply the whole thing with this one. I mean root over g by 2r. Okay, that means root over g by 2r into this whole term. So we will get our final answer. Okay, so that will be the time that we will definitely need to break off the plane. So let us think that the r is equal to 1 meter. Okay, so if the r is equal to 1 meter, then let me some calculate 9.8 divided by 2 multiplied by integration integration point 0.00000 with 1 2 3 4 5 6 7 7 1 integration cos inverse 2 by 3. So now 1 divided by root over x minus sin x. So if I am not wrong, so this is the t. So the final t that is coming is so let us wait. Let us see what results our calculator is going to yield us. Because you can simply, and that is almost 30 seconds. That means 30 seconds. So that will be the answer. Whereas the answer that was given to us was 0.39 seconds, which is not even close to the actual answer. Because you can just simply understand it why this answer seems logical. I want to tell you, because you can see here, please look some here, because when you just let us zoom in, okay, so when you just go there, okay, so you give just d theta, okay, so the torque, so mg sine theta, but theta is very small, mg theta. So so the time that you will need to go this distance, the time you really need to go this small distance will be very larger than the time you need to go this distance. Can you understand? Because mg theta, the theta is very small, so it cannot even generate the torque that is even needed to circulate the object around this circular hemisphere. Okay, so we have to properly understand that. So the torque is changing, and that's why it will take very in a big time to cross this. But you can even see that the time it is needed to cross this section will be the total time that it needs to cross this section, because of the change in the torque in huge amount. Okay, so that is the thing. So I think I was able to make clear everything. So if you find any sort of problem, or if you find any inconvenience, please you can make me remember, or you can tell me just, so I will try to solve it. Okay, and thank you.